If you're anything like me and you've been in FPV for a while, you probably have a growing collection of broken components. And this project was something that I designed in order to use those up. So the first thing to do was to test it on land. I have first designed this single piece 3D printable one, which looked really cute. It has sort of chibi look going on. But honestly, it was garbage. It did not work on water at all. I don't even have any footage of it working on water because it was rubbish and it sank. But here it is zipping around on a hard concrete floor, and at that it was pretty awesome. So Mark II, I decided to use just a bit of balsa wood, go real old school. You can see I've float testing it in a bucket, looked pretty convincing. This version had a tendency to flip right on its face anytime that you did a cornering maneuver at all, since the front corner would dig into the water and then pivot over. So I added a little plastic sheet on the front which prevents the nose digging into the water, and you can see flight or water testing here on just a bit of water in the top of a plastic container lid. It's reasonably decent. So some quick testing just indoors in a pail of water, and it's looking pretty decent. So off we go back to the lake to try it out. Prepared this time, and here we go. Looking pretty promising. Zipping around gets a decent little bit of speed going on. The balsa wood is very light, so it floats pretty well. Oh, and there we go, on our face again. Brilliant. Should probably mention here that I have thoroughly conformal coated the whole board and all of the electronics, so that is how they're managing to survive these dunkings. I should also mention that if you are really going to try this, which I probably recommend that you don't, you need to be triply sure that you have conformally coated everything thoroughly, and you should still be willing to burn up some electronics because there's a good chance it's going to happen. Mark III was another 3D printed version. Again, this time I'm using a removable power pod at the top, which houses all of the electronics and the motors and the FC, etc., onto a hull which is 3D printed. And the hull is completely hollow and printed vertically on its tail, so it doesn't require any supports or infill or anything, so you get a solid, hopefully watertight if you print it well. And here you can see it worked. But it was very difficult to get up to a planing speed, and due to those sort of sharp corners, I think, on the front of the nose, it would dig in when cornering and sort of spin out. So I was over to the CAD machine and started whipping up a new power module. You can see it's a really simple design. It is designed to clip directly into the hull and print on its tail, so there's just two pieces to print. This one holds two 1202 motors on the back, a Whoop flight controller, and then the battery sits inside. The battery sits in a little sled which actually keeps it above the surface of the water, and even the water that does get into the boat will sit underneath, hopefully, the battery, so it doesn't sit in the water all the time. Little exploded view there to show you how it goes together. All it requires is motors for the screws for the motors and screws for the FC. The motor wires will probably require a bit of lengthening, but that's easy to do. So off to the 3D printer, and bada bing bada boom, magic of technology. There we have some plastic. You can see the power pod just slips in with a friction fit. The 3D printer is actually designed to flex slightly so that it's locked in place perfectly, which works really, really well. This version now is actually working pretty darn decently, and I was quite happy with it. It's good fun to buzz around. and since it doesn't flip over, it doesn't get the electronics nearly as wet, although they do get wet, so still conformal coating all the way. I'll share these files and I'll share the configuration and setup, etc. You'll be able to find it on Newbie Labs, but it probably does require a little bit more fine tuning on the tuning, which hopefully some sort of tuning expert can weigh in on. So if you are that guy, let us know. I'd love to see anybody who does actually go ahead and build this thing against my recommendations and puts your electronics on the line, as it's kind of fun to buzz around. The biggest problem with it really is the fact that when the antenna gets wet, it really messes with your signal, quite obviously. So if you could find a way to keep the antenna from getting wet, that would be ideal. And again, also, even having water on the board when it's properly conformally coated can mess up all the carefully designed RF circuitry on there and also affect your video quite badly. In reality, perhaps a micro airboat is not the best idea, but it was pretty fun to do anyway. I'm going to list all of the components that I used in the description and in the build, but basically this was using a newbie drone B-Brain. I used a V1 or V2, which had a ESC that was damaged, so it's a great way to reuse your old electronics that have been damaged due to some sort of flight incident. I'm also using 1202 flow motors and 2.5-inch Avan Rush props, and the Goober canopy and the BI camera. So if you're flying whoops and micros, you're guaranteed to have this stuff lying around, and maybe it's worth a go. Thanks for watching, hope you enjoyed it.